Hi guys, how are you? Just a quick clip here for you on to do with calculating the pH of bases. So we looked at strong acids the last day, not the last day, like 5 minutes ago, literally when I made that one. But the what we're looking at now is strong bases. Okay, so strong bases behave very like strong acids. They dissociate completely in water. Okay, and I've written this down here because I want you to just think about when we talked about Kw before. Okay, so we talked about Kw. And Kw is all about a constant, isn't it? That water, that sort of pure water, always has the same concentration of H plus or H3O plus. They're basically the same thing. Ions in water, and that number is 1 by 10 to the minus 7. So the greater that number is, the more acidic something is. If it's greater than this value, you have an acid. If it's less than this value, you have a base. That's basically what that is. It's kind of like a magic number. If you tip over one side, you've got an acid. You tip over the other side, you've got a base. And usually we express this in terms of minus the log for reasons we went into the last day, just simply because it's less clunky. It's an easier number to understand, 7, isn't it? Than 1 by 10 to the minus 7. So the minus the log of these H plus ion concentrations will give us 7. The higher this number, the lower this number. That makes sense, doesn't it? Because it's minus the log. It's just a function, a mathematical function of that. All right. Now, if we're looking at bases, very often what happens is that as H plus decreases, so if this number goes down, the amount of OH minus ions, because remember we're talking about aqueous solutions here, so the other half of that H plus is OH minus. The more OH minus there is, the stronger the base. So it makes sense, this is a question mark by the way, it looks like a 7, but it's a question mark, to work out what that concentration is. What is the concentration of OH minus ions? Sometimes that's important, particularly when it comes to bases, to work out, okay? So in much the same way, we can calculate or we can work out the concentration of OH minus ions, which will tell us how basic something is, right? And we often express that in terms of POH, minus the log of the OH minus ions, okay? For the simple reason that that's an easy number, okay? And it turns out that this is a balance, okay? The more H there is, the less OH there is. The more OH there is, the less H there is. And the sum total of these, of pH and POH, has to be equal to 14, okay? Because the sum total of H plus ions plus OH minus ions has to be equal to 1 by 10 to the minus 14. Remember we mentioned that when we were talking about Kw. So we're just getting the minus the log of that number, which is 14. That's where that comes from. So all of that means that if we want to get the pH of a base, what we can do is, if we have the correct information, is we can work out the POH, in other words, get the concentration of OH minus ions, get minus the log of that, subtract 14 from that, and we get the pH, okay? So I've just literally brought the POH over here, 14 minus that gives us that one there. All right, this is it doesn't come up very often, it's only a little thing, and I just want to do one very quick example just to show you how that looks. Okay, so the example I'm going to look at is 2006. So in 2006, there was a question on question 4. I think it was part I. I'm not sure that was an I think. You'll find it anyway. It's one of the short questions. And they said there's a sodium hydroxide solution. It's got 0.2 grams per litre. What is its pH? Okay, so we're going to do that one together. Now, you should hopefully be able to, at this stage, convert grams per litre into moles per litre. Easy enough. You go to your periodic table and you work out that 1 mole of NaOH is equal to 40 grams, right? 23 plus 16 plus 1. That's not a big deal. So how many moles per litre do we have? Well, we've got 0.2 divided by 40, which is equal to 0.005 moles per litre. Okay, so the concentration of my sodium hydroxide in moles per litre is 0.005. That's not a big deal. That's the concentration of OH minus ions, because remember, this is a monoprotic base. For every one of these, there's one OH minus as well. So I'm going to get minus the log of 0.005. Okay, I put these in square brackets because they're concentration. Put that into my calculator, and when I do, I get 2.3. All right, so you can try that yourself. Minus the log of 0.005 is equal to 2.3. This is the concentration of OH minus ions in solution in this base. So the POH of this solution is equal to 2.3. Now, usually we don't express POH. We express pH, okay? So how do I change POH to pH? Easy peasy. 14 minus 2.3, back to our equation from the last slide, or whiteboard, is equal to 11.7. And that's my pH. Makes sense, doesn't it? And again, in some ways, these are very easy because you know if you're doing it right or wrong, if you're getting the right kind of answer or not. This is a respectable pH for a base. And so you have a fair idea that you're doing it right. just remember this last step. It's easy to forget it. It's easy to just do the minus the log bit and walk away. And remember, obviously, then you won't have got the full marks. You'll probably have dropped 3 marks. Okay, but it's not particularly difficult. It's just one to have in your back pocket in case it comes up. It doesn't come up very often, but when it does, it's quite easy. All right, hope that helps. Bye-bye.